Hey, so hello everyone. Last meeting, we're able to talk about the product rule, have some examples, and then the chain rule. And we've already begun going over how derivatives of higher order are obtained. So today, let's have more examples for the three of them. Okay. So suppose we have a function y equals the fifth power of 2 over x minus 1. If we were to disregard first this external quantity and this exponent, we have a fraction. Basically, it gives us an idea that we can use quotient rule. Okay. Now, what we can do here is to treat this as chain rule, since together with this quantity and this exponent, so we can see that it is a composite function. Okay, wherein the inner function is this rational expression, and the outer is trying to raise this rational expression into the fifth power. Okay, so we can set y as a function of u. So this will be y equals u to the fifth power, in which dy du, applying general power rule, this would be 5u to the 4. Likewise, let's get the derivative of 2 over x minus 1. Okay, this will be u equals 2 over x minus 1. Okay, now another way that we can see this, aside from treating it as a quotient, is by using the negative exponent of the denominator. So this is also equal to u is equal to 2 times x minus 1 to the power of negative 1, since it would be more convenient compared if we were to set this as so u, then v, and then we'd have to apply quotient rule, so it will be longer. Okay, so here we can apply power rule. So du dx is equal to 2 times negative 1 is negative 2 times, so this will be the u. So if we were to set this, say u na ni u pa dyan ni, no? So power rule, this is our n, so n times 2 and then u to the n minus 1. Okay, but then let's just put it as is. So it is x minus 1, then negative 1 minus 1, this will be negative 2. So another way to write this would be, so du dx is equal to negative 2 over x minus 1 squared. Okay, so now we can get dy dx, wherein dy dx is equal to dy du times du dx. Okay, dy dx is equal to, so dy du is 5u to the 4. But this time, let's write u, which is 2 over x minus 1. So this will be 2 over x minus 1 to the oh, what happened? Okay, u, which is 2 over x minus 1 to the power of 4, multiplied by du dx, which is negative 2 all over x minus 1 squared. Then simplify, dy dx is equal to, so we're going to multiply, we can multiply, so this is raised to the fourth power. So it's either we're going to raise both the numerator and denominator, no, to the fourth power. Okay. So this will be now 5 times negative 2. So that will be negative 10 all over x minus 1 squared, then times 2 to the power of 4. So that would be 16. Okay, so that would be 2 times 2, which is 4, times 2 is 8 times 2, 16. Okay, that would be 16. And then raise x minus 1 to the power of 4 also. Okay, simplify. So we have here, so loss of exponents, a product. So this will be 2 and 4 will be added. So dy dx is equal to, so the numerator is 10 times 16. So that would be 160. Don't forget the negative sign here. All over x minus 1 to the power of 6. So this is now dy dx. Okay. Wherein here we applied chain rule and simply general power rule. Okay. Let's have another example. So this one, so this is still similar to the previous example, but this time it is more obvious. Or how about what if we try using quotient rule? Still we can just use we can use general power rule, but since we have here variable raised to a certain power, tendencies would be applying chain rule inside a chain rule. Okay, so it's more convenient if we use quotient rule. Okay, so before we try to apply quotient rule, let's find first the derivative of the term inside the radical sign. Okay, let's find first the derivative of x squared all over x minus 4. Okay, now the derivative would be, so here, say for example, let's call it, so u lang gihapon, no? Okay, let's call it u. U equals x squared all over x minus 4. Okay, meaning du dx will have to be, so applied with quotient rule. So what we could do here is we could set, so here set this as, say this is f and this is g. Okay, f is equal to x squared, g is equal to x minus 4. Okay, taking df with respect to x, this would be 2x. Okay, taking the derivative of g with respect to x, this would be 1. Okay, now what we'll do here is we're going to use quotient rule. Now recalling quotient rule, so here we have v du dx minus u dv dx all over v squared, and this is equal to the derivative of a quotient. Okay, diba? Now here, in our example, our variables used is actually f and g. So what will happen here is the derivative of f over g with respect to x is equal to, so g df dx minus f dg dx all over g squared. Okay? Dapat ito nga, assume ko na sila aligned. Okay? I hope you get the assignment of variables. Okay? So now let's try to get du dx. Okay? Du dx is equal to, So I should have made the background black. Anyway, you can judge me. I don't have much on color theory. So we have g, which is x minus 4, df dx, which is 2x, okay, minus u, or our f, which is x squared, times dg dx, which is 1, okay, all over the square of g, which is x minus 4 squared. Okay, so simplify, we have du dx is equal to, so this will be, so we have here 2x squared minus 8x minus x squared all over. So you can say, you can either uh, square this, no, like expand x minus 4 times x minus 4, or simply, so square away binomial, square the first term, twice the product of the two terms, square the last term. So that is our denominator. Then combine like terms, du dx. Okay, let's just have it this way. Okay, now we have here 2x squared minus x squared. Okay, so 2 minus 1, simply 1. So we can just leave x squared. Okay, and then this time, since we have now our derivative, we can now apply the chain rule wherein y is equal to u, or the square root of u. Okay, we have green. Okay, here y is equal to the square root of u. Okay, now dy du is equal to, we have here du dx, so simply 1 over 2 square root of u. Okay, dy du pa ni. Okay, and then if we were to get dy dx, so this will be dy dx equals dy du, which is this one, times du dx, wherein we'd have to restore u. Okay, now this will become x squared minus 8x. Okay, so du dx all over, this is x squared minus 8x plus 16. Okay, now where's the eraser? Okay, na-erase siya tanan. Okay, let me, this is du dx times, so dy du, so 1 all over 2 square root of x squared all over x minus 4. dy dx is equal to x squared minus 8x all over, distribute 2, this is 2x squared minus 16x plus 32 times the square root of x squared all over x minus 4. Now this is now dy dx. Okay, so what we did, we simply get it, du dx by quotient rule. Then this is chain rule. Okay, so earlier we have still a quotient, but we used general power rule since it's more convenient for this rational expression. Here we have here variables, so we opt for quotient rule. Okay, now there are times when we'd have to use multiple techniques with one function to find its derivative. Okay, if we were to look at this function, y equals, so we have the cube of x minus 5 multiplied to the fifth power of x squared plus 5. And if you try to analyze, you can see that possible rules to apply would be chain rule and product rule. Since these two quantities, okay, are products. But then, to find their derivatives, we'd have to get the derivative of this whole function, we have to use chain rule. So, how are we going to do this? Okay. So, it's either you have to set them as separate or find their derivatives separately, which is what we're going to do. Okay. But before that, let's try to assign them. One will be u and one will be v. Suppose we set u as this the first, say, first term. Okay, term na lang. The first term would be u, which is the cube of x minus 5. Okay. Now, looking at this, we can say chain rule again. Okay, diba? So, this is chain rule. So, this is a product of two chain rules. Something like this or like that. Okay. So, now, if we were to take its derivative with respect to x, okay, forgo with assigning pa jud nga, u pa jud ning susulod. Okay, we already understand that the derivative of this function would be, so du dx would be equal to, apply general power rule, that would be 3 times our supposed u or supposed inner function, then we have to retain it, that's x minus 5, and then 3 minus 1, it's actually 2. So that would be squared times du, or the derivative of the inner function, it's only equal to 1. Okay, so na siya times 1 there. But then, let's just not write it anymore. Okay, so that would be our du dx. Now, if we assign the second term as v, here, the fifth power of x squared plus 5, so this will be x squared plus 5 to the power of 5. The derivative of v with respect to x is equal to, so more or less similar to what we did here. This will be 5 times x squared plus 5 to the power of 5 minus 1, which is 4, times the derivative of the inner function. The derivative of x squared plus 5 is 2x. Okay? Now, rewriting, simplify, this will be 10x times x squared plus 5 to the power of 4. Now we have u, we have v, we have du dx, we have dv dx. We can now apply the product rule. Okay? We're in the product rule, so dy dx is u dv plus v du with respect to x. So dy dx is equal to u, which is x minus 5 cubed, times, so dv dx, so we have here 10x, okay, times x squared plus 5 to the power of 4 plus v, which is x squared plus 5 to the power of 5, times du dx, which is 3 times x minus 5 squared. Now, simplify or rearrange, dy dx is equal to, so we have here 10x times x minus 5 cubed times x squared plus 5 to the power of 4 plus, we have here 3 times x minus 5 squared times x squared plus 5 to the power of 5. This is now dy dx. Wherein there is chain rule, then inside each chain rule is another chain rule, no? And then we have product. Okay? So more or less you get the concept. Hopefully you do. Now, let's have an example. Say we have y equals 5w squared minus 1 raised to 4/3. And we are asked to differentiate up to the second order. Okay? Now, when you try to assess this function, we can say that perhaps we can apply chain rule. Well, definitely we can. Okay? And then another thing would be, so here we have here say general power rule, and this is just a constant. So what we could do here now is set our inner function as u. So this will be u equals 5w squared minus 1. Notice we have a different independent variable. And I actually intended that so that you will not be surprised if you're given another variable. Sometimes it will vary depending on the quantity and the variable it will depend on. Okay. So consider this as a practice. Now we have u equals 5w squared minus 1. Meaning to say we'd have to find du with respect to w. Okay. Now du, or the change, or let's say the derivative of u with respect to w, still the same rules apply. This will be 10w minus 0, or simply 10w. Okay. Now let's try to apply now. So chain rule. We have here y equals u to the power of 4/3. So we'd have to find dy with respect to u. This is simply general power rule. So this will be 4/3 u to the power of, so 4/3 minus 1. Okay, 4/3 minus 1, or simply 4/3 minus 3/3, that would be 1/3. Now we have dy du. We also have du dw, and y and u. So apply chain rule to find the first derivative. Okay. So we have here dy dw is equal to dy du, which is 4/3 times the inner function 5w squared minus 1 to the power of 1/3 times du dw, which is 10w. Then rewrite. So this will be dy dw is equal to 40w over 3 times 5w squared minus 1 to the power of 1/3. This is our first derivative. First order derivative. This time, let's try to find the second derivative. And how do you think are we going to do that? Okay. So this time, still we can use chain rule. Okay. We can actually use chain rule. Okay. Wherein our u will be this term, 40w over 3. And our v would be this term, this one. This can be our v. This will be v. Okay. Now, let's try to get du dw and dv dw to find the second derivative. Okay. So from there, if our u is equal to 40 w over 3, du with respect to w will now be 40 over 3 times 1, or 40 over 3. On the other hand, if v is equal to 1/3 power of 5w squared, or simply the cube root, if you think about it, it's a cube root, then dv with respect to w, so we can apply here chain rule, power rule. This will be 1/3 times 5w squared minus 1 to the power of 1/3 minus 1. It's negative 2 over 3 times the derivative of our inner function. So that would be 10w. Okay, do not forget the derivative of the inner function to be multiplied at this end. Okay, so dv dw is equal to 10w over 3 times 5w squared minus 1 to the power of negative 2/3. Okay, or so you can simply, let's just put it as is, and then let's simplify later. Now this time we can now get our second order derivative by applying product rule. Okay, so here we have here a product, remember, u times v. Okay, so taking the second derivative, which is, this is dy, so to the second order, divided by, or with respect to w to the second order. Our u is 40 w over 3. Okay, let me write this in ink para in case you will be wondering, okay, where it's coming from. So 40 w over 3 u dv, this will be times 10w over 3 times 5w squared minus 1 to the negative 2/3, and then plus v, which is the cube root of 5w squared minus 1 times our du, which is 40 over 3. So 40 over 3. Now this time, let's combine like terms to simplify. Second derivative of y with respect to w is, so this will be 400. Okay, 400, then w squared all over. So since this is a negative exponent, so expect it to be applied or placed in the denominator. So this is 400 w squared all over 3 times 3 is 9, then times 5w squared minus 1 to the power of 2/3. Okay, let me write it that way na lang. Plus, so 40 over 3 times 5w squared minus 1 to the power of 1/3. Okay, and this is now our second derivative. And if you notice, so there is a pattern, no? If you try to go over, there's a similarity between the first derivative and the second term of the second derivative, wherein the variable is beginning to diminish. Okay. So if you were asked to differentiate up to the third order, so that would mean you'd have to differentiate this again. Okay. So those are just a few of the examples. So earlier, we have had here, so this is chain rule with, this is quotient or simply power rule. Then we have here still chain rule, but then we're able to apply quotient rule. Then we have chain rule and product rule. And lastly, so higher order derivative, we're able to use chain rule, and then ultimately chain rule and power rule. Okay. So if you have any questions, so just try to comment down in the post or message me. I'll see you in the next discussion. Thank you.